In this lecture, we are going to see how to detect and correct the errors using a Hamming code. So we'll see an example here. The Hamming code 1011011101 is received. Correct it if there are any error. And the parity used is odd parity. So we have to make a table here. In that, first we need to write the bit designation. So in the received Hamming code, how many bits are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 bits are there. So we need to write total 9 bits here. And remember, the powers of two locations will be the parity bits. As we discussed in the last lecture, the powers of two locations will be the parity and the remaining will be the data. That means first location parity, second location parity, fourth location parity, and then 2 power 3, 8. So P8 is also, 8th location is also parity, and the remaining will be the data. So remaining means D3, D5, D6, D7, and D9. So total 9 bits are there. In that 5 are the data and 4 are the parity bits. Then we need to write the bit location. Bit location from 1 to 9 we need to write. Then the binary of the location. We need to write till 9. So we are taking 4-bit representation. For 1 it is 0001. Then for 2 0010. Up to the location 9 we need to write the binary. For 9 binary is 1001. Then we need to write the received Hamming code. So received Hamming code is what? 1011011101. While checking for a parity, if the parity is wrong, we need to mark it as 1. While checking for a parity, if the parity is correct, we have to mark it as 0. So remember, when we are checking for a parity, if the parity is correct, if the parity is received correctly, it should be marked as 0. And the received parity is wrong. If the received parity is wrong, that should be marked as 1. Now first we are going to check for the parity P1. So while checking for P1, we need to check the locations 1, 3, 5, 7, 9. Why 1, 3, 5, 7, 9? In the locations 1, 3, 5, 7, 9, the first bit is 1. So that is why we are grouping 1, 3, 5, 7, 9 in a group. So in for location number 1, we have the binary bit 1. In the third location, 1. In the fifth location, 0. So writing 0. In the seventh location, 1. Writing 1. Then on the ninth location, 1. So we got the binary word 11011. Now we transmitted in odd parity. So here in the received word, it is 11011. Number of ones are 1, 2, 3, 4. Number of ones are 4, which is an even number. But we transmitted in odd parity. That means the parity check is wrong here. So when the parity check is wrong, we should write it as 1. And this 1 will become the LSB. So remember, after getting all these parity answers, we need to write it in the reverse order. That means for the first parity P1 check, what is the answer? That will become the LSB. Now we are going to check the parity P2. For checking for P2, we need to correct the locations 2, 3, 6, 7. So in 2, 3, 6, 7, what are the bits we have? In the second location, 0. So writing 0 here. In the third location, 1. So writing 1. In the sixth location, 1. In the seventh location, 1. So in 2, 3, 6, 7 locations, we got the binary word 0, 1, 1, 1. Now why it is 2, 3, 6, 7 locations? In 2, 3, 6, 7 locations, the second bit is 1. See in 2, second bit is 1. In 3 also, second bit is 1. Then on 6, second bit is 1. Then on 7 also, the second bit is 1. So we are grouping 2, 3, 6, 7 locations. And from 2, 3, 6, 7 locations, we got the binary word 0, 1, 1, 1. Now we need to count the number of ones here. Number of ones are 1, 2, 3. That is an odd number. We transmitted in odd parity. We received also odd parity. That means the parity check is correct. If the parity check is correct, we need to mark it as 0. So for check for P2, we got it as 0. Now we need to check for the next parity bit P4. For checking for parity bit P4, we need to check the locations 4, 5, 6, 7. Why 4, 5, 6, 7? In the binary of 4, 5, 6, 7, the third bit is 1. In 4, third bit is 1. 5, third bit is 1. 6 also third bit 1. 7 also the third bit is 1. That is why we are grouping 4, 5, 6, 7 locations. Now we need to write the binary bits on these locations. On the fourth location we have 1, so writing 1. On the fifth location 0, so writing 0. On sixth location 1, writing 1. On seventh location 1, so writing 1. So we got the binary word 1, 0, 1, 1. So here also we need to count the number of ones. Number of ones are 1, 2, 3. So we transmitted in odd parity. Here the number of ones are 3. That means it is in odd parity only. So the check for P4 is correct. So that is marked as 0. Now the last parity bit is P8. For checking for P8, we need to check the locations 8 and 9. Why 8 and 9? In 8 and 9, the fourth bit is 1. Fourth bit means 1, 2, 3, 4. Fourth bit is 1. In 9 also 1, 2, 3, 4. Fourth bit is 1. So 8 and 9 we are grouping together. Now we need to write what is there in 8th and 9th location. On 8th location we have 0. On 9th location we have 1. So the binary word is 0, 1. In 0, 1, how many number of ones are there? 1. And that is an odd number. We want odd parity. So the check for P8 is correct. If it is correct, we need to mark it as 0. Now all these answers, okay, should be written in the reverse manner. So what we'll get here? 0, 0, 0, 1. So 0, 0, 0, 1 is equivalent to 1. That means in the received Hamming code, the first location is in error. So that is how we are detecting the errors using a Hamming code. So on the first location, we received an error, and how we can correct the code? If it is 0, change to 1. If it is 1, change to 0. So in the received Hamming code, the first location, on first location we have 1. So that should be changed to 0 to get the correct Hamming code. So the corrected code will be 1011011000. It was 01 that we are correcting it to 0. So this is the corrected Hamming code.